Hi, I'm gonna tell you how to sketch exponential functions, and we're just gonna look it with an example. And after we check the example, you should be able to sketch any exponential function. First, let's use the information of the equation y equals 5e to the 2x plus 1 power minus 3. To have the graph of the exponential function, we have to go step by step. I usually recommend to start talking about domain and range. Domain and range. Domain of an exponential function is always is always all the real numbers. So we're going from minus infinity to infinity. To infinity. Okay, this is the domain. Domain is always the same. You can use any real number here and we have the domain. Now the range. How to determine the range? The exponential function has an asymptote, and the asymptote of the exponential function, the exponential function that is of the form y equals e to the x power, the asymptote of this exponential function is 0. What does it mean? That if x is minus infinity, is going to be y equals 0. Or there's no exponent that it could get you this number less than 0. Okay, there's no exponent. You cannot rise to an exponent x to have the function less than 0. But what happened here? Here we have our exponential function and it says minus 3. Minus 3 means that we move the asymptote from 0 to minus 3. So we know that one of the boundaries of the limits of the range is minus 3. Now we need to check if the function is going to infinite or is going to minus infinite. How could we calculate that? Checking the exponent of e. The e is going to tell us that if we're going to infinity or minus infinity. If the number that multiplies e is positive, so the function is going to infinity. If the number that multiplies e is negative, the function is going to minus infinity. In this case, it's 5, so it's a positive number. So the function is going to infinity. Domain and range. We determine domain and range. It means that our function, we don't know the form yet, but we know that our function it's going to is going to have a range that starts here at minus 3 and until infinity. Okay? Now, let's continue. We determine domain and range. Now we have to pass to the next step. The next step I usually follow to have the exponential graph is to have the y-intercept. The intercepts. So first, y-intercept. 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 Remember that y-intercept is determined when the equation is 0, 0, 0. Oh. When the equation is when x equals to 0. So we're going to set x equal to 0. What happened here? So we have 5e minus 3. Here you have to use your calculator to have the answer. 5e minus 3. So let's use the calculator. So 5 times e minus 3. Okay, so this is the answer. 10.5914. Okay, you can write 2 decimal places. 10.59. So 10.59. 10.59. 10.59. This is the y-intercept. Let's use annotation to say that this is y-intercept. 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 Now you can set the x-intercept. X-intercept. Oh, excuse me. X-intercept. X-intercept. And the x-intercept is when y equals to 0. So y is 0. So we gotta solve the equation. Let's solve the equation. So 3, we can add both sides by 3. Now let me divide by 5 to each side of the equation. And we have this equation. How to solve this equation? To solve this equation, you have to use something called the logarithm, okay? And we're going to apply properties of logarithms. So e, if you apply the natural logarithm, you will have that natural logarithm of e to the 2x minus 1 is the exponent 2x plus 1. And here we have to apply the natural logarithm. Natural logarithm. Let's see if we have the natural logarithm here. Okay, natural logarithm. And we have to solve this equation. Okay, you can do the steps to have the answer, that is x equals to natural logarithm of 3/5 minus 1 divided 2. And of course, let's get it. Let's calculate it. Then you have to use your calculator. X equal to, so natural logarithm, okay, let's find here how to do it. Natural logarithm is here. Natural logarithm of 3 divided 5 minus 1 divided 2 minus 0.75, and it's 5, so we're gonna round it to minus 0.76. So we have y-intercept, x-intercept. Remember to set something to tell you that is the x-intercept. You can write like a 0, okay, to say that x-intercept is 0. Here 0. So we have the x-intercept, we have the y-intercept, and we have the domain and range. Domain and range. Domain and range. So we just have here to set the points. So we know that the y-intercept is y-intercept is 10.59. 10.59. So here is 10.59 and 0. And b is minus 0.0 here and minus 0.76. Okay, we can see b here. Okay, we're gonna try to move this. Okay, so here you could see the points. Okay, the points, and the asymptote will be the equation x equal 3. Excuse me, we said that the asymptote is minus 3, so y equals minus 3. So this is the asymptote. The graph couldn't pass by the asymptote, and you could see 2 points here, x and y-intercept. Exponential function form is the same. Should start from the asymptote, passing to the points and going into infinity. Okay, depending on the range, so the exponential function will have this form, or this form, this, or this. As we found the x and y intercepts, we know that starts from minus infinity, is going to move, pass by this point, and getting up. So finally, we just have to do the graph. So y equals 5e 5e to 2x plus 1 minus 3. Okay, look at the function is going through the asymptote and turns to infinity. You gotta be very careful here because the function is not actually touching the asymptote. Okay, It's not intercepting the asymptote. It's really near, close to the asymptote, but is not passing by the asymptote. And this is how you sketch an exponential function. I hope that you enjoy the video, and I hope that you understand how to sketch an exponential function. Thank you for watching.